Good day, everyone! We are here to share what we know about electricity and magnetism. But before we start, here are the following questions we need to answer while we proceed to our discussion. First, how is electricity related to magnetism? Second, how does electricity produces magnetism and how does magnetism produces electricity? The third and the last question is, what is electromagnetic induction? So let's start! Here is a brief history about our topic. In 1819, Hans Christian Ørsted, a professor in the University of Copenhagen, discovered during a class demonstration that a current carrying wire caused a nearby magnetized compass needle to deflect. His observation fired up tremendous researches on electromagnetism. 12 years after this discovery, Michael Faraday conducted his famous induction link experiment showing that current can be produced by sources of changing magnetic fields. Shortly after, in 1835, Heinrich Lenz showed that the EMF always gives rise to a current whose magnetic field opposes the original change in the magnetic field.
What is magnetism?
Magnetism is the physical phenomenon produced by the motion of electric charge, resulting in attractive and repulsive forces between objects. Magnets either exert a force of repulsion or attraction.
Materials which are attracted by a magnet are known as magnetic materials. Iron, cobalt, nickel, and many alloys of these metals like steel and non-nickel magnetic.
How does electricity produces magnetism and how does magnetism produces electricity?
Electricity and magnetism are two very important topics in the science of physics. These two are really different parts of a single force. A moving magnet makes electricity and an electric current makes a magnetic field. We use this fact to build motors and generators. We use electricity to power computers and to make motors go. Magnetism makes a compass point north and keep notes stuck on our refrigerator. Without electromagnetic radiation, we would be all in dark, for the light is one of its many forms.
There are two types of electricity, static electricity and electrical currents. Static electricity stays in one place, like the charge on a doorknob that can zap your hand in the wintertime. Electrical currents moves and flows, like the current in the wires in a lamp. Some of the particles that make up atoms, including protons and electrons, have small electrical charges. Humans have learned to use electricity in the last couple hundred years. Our modern world uses lots of electricity in many ways. Electricity has changed the world a lot. Electricity's nature is also important. Natural electricity makes lightning flashes and the signals that flow along our nerves.
Magnetism is electricity's close cousin. Some materials, such as iron, are attracted to magnets, while others, such as copper, are not. We use the idea of magnetic fields to show how objects move when they are near magnets. Magnets have north and south poles. Two poles that are the same, like north and north, push each other apart. Two poles that are not the same, north and south, pull each other together.
Electricity is created by flow of electrons. Each electron contains electric field. As the electrons move or spin in the same direction, they produce a field called magnetic due to the electron speed of the electrons. The magnetic field in a magnet is created due to the unpaired spinning electron or free electrons. If you move a magnet inside a coil, it produces electricity. As it states that a changing magnetic field produces electricity. It can be demonstrated in generators.
Magnetic fields and electric currents makes waves of energy that flows outward into the space at the speed of light, which is very, very fast. These waves of energy are called electromagnetic radiation. There are 6 kinds of electromagnetic radiation. First, the light. The light that we see with our eyes is one kind. Ultraviolet and infrared light are invisible to us, but some animals and insects can see them.
Radio waves have very long wavelengths. X-rays and gamma rays have very high energies. When broken down into their constituents by spectroscopes, electromagnetic spectra reveal much about distant objects such as stars. Humans use our knowledge of these electromagnetic radiations. We build telescopes for viewing the heavens, radios to communicate, and X-ray machines for check for broken words.
Our society uses electricity in many ways. Generators in power plants change heat from steam into electricity. That electricity flows along wires to our houses and schools.
We flip a switch to turn on a light, a pan, or a dishwasher. Chips and computers use electricity to think and calculate. Small electrical currents carry information like this web page over the internet to your computer screen. What is electromagnetic induction?
Electromagnetic induction is a phenomenon in the production of an electromotive force across a conductor when it is exposed to a time-varying magnetic field.
Electricity and magnetism is one of the important concepts in physics and in our lives.
Without these, our world won't have paper-bound technologies that will help us in our everyday struggles.
So we should give thanks to the people who discovered these ideas.
The three of us are hoping that these ideas helps you to understand how important and amazing this concept is. Thank you.
Thank you. Bye-bye.
do 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 do